In the previous video, we discussed the periodic table and how it is improved by chemists to become a better catalogue of elements as we know today. They were collected and listed in order of increasing atomic number. The elements were put into vertical order called groups with other elements that reacted similarly to them. The periods of the periodic table tell us the number of shells or orbitals an atom is made up of. For example, sulfur is found in period 3, which means the sulfur electron configuration consists of 3 shells. Calcium is in period 4, so the atoms will have 4 orbitals. The periods start with the number 1 and go all the way up to 7, meaning the biggest atoms will have 7 shells. Knowing this is super helpful when drawing atoms because it tells you how many circles you need to draw. You can look at the atomic number to tell you how many electrons you have to spread out between those shells. There are a few patterns known as trends of the periodic table that we need to know about. The first trend is atomic radius, which also determines atomic size. An effective atomic radius is the distance from an atom's nucleus to its outermost orbital, about which 95% of the electron density is found. This can be measured as half of the internuclear distance, and it decreases across a period. So, as you go from left to right across a period, the atoms get smaller. This is because electrons are being added to the same shell. Why does this matter? Well, the outer shell electrons are being pulled inwards by the positive protons in the atom's nucleus. So, the more electrons on the outer shell, the stronger the attraction, which means the more inwards the atom will be pulled in, so the smaller it'll be. This attraction pulling the electrons inwards is called the electromagnetic attraction. The next trend is ionic radius, which is the radius as atoms form ionic bonds. It generally decreases as you go across a period from left to right. This is because there are more protons in the atoms, but with the same number of shells, and so the electrons on the outer shells are subjected to electromagnetic pull, pulling them inwards. While forming bonds, cations are smaller than its parent atoms as electrons are removed from the outer shell. Anions are therefore larger than the parent atoms as electrons are added to the shell, resulting in increased repulsions between electrons and a decreased electromagnetic attraction due to the protons being outnumbered by electrons. This makes the trend a bit complex. Knowing about the atomic radius and ionic radius is very important. It not only gives the information about electron distribution, but also helps us explain the behavior of atoms of an element such as energy and reactivity. However, being informed about trends in radius is not enough to understand the periodic table thoroughly. So, in the next video, we will dig deeper into other trends in periods, ionization energy, affinity, and lastly, electronegativity.